Mind Stretchers is next on BBC One this morning. It's in just over a minute.
Suppose you want to build a bridge across this river. Like most problems, there are a great many solutions. The type of bridge chosen depends on the width of the river and the height of the banks, the size of the ships which need to pass underneath, and the amount of traffic which needs to cross it, as well as other factors, such as the type of building materials available, and the designer's view of what looks attractive. Although it looks as though there are lots of ways of building bridges, in fact there are only 4 basic types. The simplest type is the beam bridge. Originally this was a log or a slab of stone put across a river. And because all the weight is on the ends themselves need to be very strong. And the beam itself needs to be rigid, otherwise the bridge will sag. A variation of the beam bridge is the cantilever bridge, and this can span longer distances. Here, the weight on one end of the pier is counterbalanced by the weight on the other end of the pier. If you take the weight away, the bridge falls down. The arch is a particularly pleasing shape and very strong. The weight of the road is taken by the arch outwards to the sides. And there are arch bridges 2,000 years old that are still standing. The longest bridges are usually suspension bridges, and here the roadway is hung by cables slung over high towers. The weight is taken by the towers, which need to be very strong, and by the cables, which need to be particularly well attached. What we're asking you to do is to build your own bridge using any one of those 4 designs, but it has to meet certain conditions. It has to span a gap of 500 millimetres, which is about that, and it has to be strong enough to take a weight of 500 grams anywhere along its length. And you can only use these materials: card, string, glue, and drinking straws. Now, obviously, the card itself isn't rigid enough to make a roadway on its own. So here are a couple of ideas which might help you to strengthen it. That's a box girder. And as you can see, it's much stronger than a piece of card all on its own. And you could make a triangle. And that would also be rigid enough to strengthen your structure. Engineers building bridges don't just start to build the bridge straight away. They make detailed plans like these. They also build and test parts of the bridge before they put it all together. You should try to do these things too before you begin. Of course, your plans don't have to be as detailed as those, but you should try and decide what sort of a bridge you're going to build and how you're going to use the various materials available. And it's probably a good idea to build and test your roadway before you put your bridge together. Good luck and have fun.
Six. 1.
We set you the problem of building a bridge. We asked you to use only card and glue, drinking straws, and string. How did you get on?
And then it will go down and like...
These children worked in groups of 3, setting their tables out with a 500mm gap between them. The first step was to decide what sort of bridge to build and draw up plans. While some of the plans looked simple enough, others were clearly very ambitious. The question was, could the bridges be built and would they support 500 grams? In the problem programme, we showed you how to make a box girder, and we also mentioned what a strong shape the triangle is. Darren's group put these 2 ideas together and made a triangular box girder. As the card they were using was only 30 centimetres long, they had to connect 2 girders together to bridge the gap. Many of the groups didn't allow enough overlap when making joins like this, and this led to a weak spot in their constructions.
Next, we're gonna make 2 more of these and put them on either side. Is it gonna be a flat top? Yeah. And we're gonna have sort of like things coming out to balance it. Balance it's like one roll.
I'm sure it's going to take 500 grams.
And it's going to try and take 500 grams.
Meanwhile, Marcus, Giles and Paul were making the 4 pillars of their suspension bridge. In order to strengthen the pillars, Giles is sticking straws round the outside of a roll of card. Then an outer layer of card is added to produce something rather like corrugated cardboard. The roadway or deck of the bridge is made by reinforcing a piece of card with a bed of straws. Loops of string are stitched into the roadway from which the bridge will be suspended, and then cables are threaded through the loops. It works, but now there's the problem of running the cables over the 4 pillars and anchoring them to the table. If you tried to make a suspension bridge, you probably encountered much the same problem.
Hang on. How are we going to support it?
And here's the bridge completed. But is this next one a suspension bridge? In fact, most of the groups made beam bridges. It is possible to span the gap using very few materials, but will this one be strong enough to carry 500 grams? Danny's bridge passes the test, and so does this one. Quite a few groups used up more materials than they actually needed, so have a go at making another bridge. This time, use any materials you like, but see how light you can make it. You should be able to do it using less than 30 grams of building materials. The suspension bridge is still not very stable, but it works, just. All the bridges supported 500 grams. Anne's takes a whole kilo.
Let's try another one, go on. I'll do it.
It's got a sag fall.
But you can be too ambitious.